Okay, sorry I couldn't be with you guys today. We are going to learn how to divide polynomials, and it's using long division. So the notes will be fairly short today, and then you're going to be doing your quiz corrections, and then you're going to be working on classwork number 23. It is on my open math. It wasn't working too well. They were having problems with their website, so I hope it's working for you today. Also, if it doesn't work, you can work on the homework. We can just put the book on the overhead, and you can work on that. Okay, so today we're going to be talking about section 5.4. And it's long division. Try to write as neat as I can on this board. Okay? But first, what I'd like to do is kind of review the steps of long division. From elementary school. Okay, so suppose I wanted to, let's see, divide 8,731 by 14. Okay, so the 14 is called the divisor. So this right here is called your divisor. He's doing the dividing. And the 8,731 is called the dividend. That's what's being divided up. And your answer is called a quotient. So up here we'll go the quotient. Okay, so let's review how to do this. We first look at the 14 and say, does the 14 go into 8? And no, 14 does not go into 8, so we look at 14 going into 87. How many times does 14 go into 87? 6, so we put a 6 at the top. And then we multiply the 6 times the 14 to get 84, and then you subtract. So you get a 3. Then you carry down the next digit to get 33. And then we say, how many times does 14 go into 33? And the answer to that is 2. Then once again, we repeat the process. We take the 2 times the 14 to get 28, subtract 5, carry down the 1. How many times does 14 go into 51? That answer is 3. And then we say, okay, 3 times 14 is 42. We subtract and we get 9. Okay, 9 is our remainder. Now, I know a lot of you in elementary school learned to put R9. Well, R9 is not a number. Or you learn to put a decimal place and put some zeros and keep going. But what we want to do is end it here, so we turn it into a fraction by putting remainder over divisor. So we have 8,731 divided by 14 is 623 and 9/14. Okay, now we're going to apply that same method for dividing polynomials. So let me get a new screen here. Okay, so, but before we do that, I want to remind you of a couple of rules for dividing polynomials. First rule, all polynomials must be in standard form. Okay? And that just means in decreasing order of degree. Second rule, and this is something we'll see a little bit more of in the second example we're going to do today. You must have placeholders for missing terms. Okay, and you'll see that in a few minutes. Okay, so let's take a look at an example. Okay. Example 1. I have to try to write small. X cubed minus 5x squared plus 4x minus 2. Fix that. Divided by x minus 2. Okay, so in this case, our divisor is the x minus 2. And the dividend is x cubed minus 5x squared plus 4x minus 2. Okay, so like I said, this is going to work similarly, just a little bit different than long division. So the first thing we start out with is looking at this x and this x cubed. And I can say to you, how many times does x go into x cubed? And that's a little bit of a complicated statement. What seems to make more sense to people is if I say, what do I have to multiply x by to get x cubed? And that answer is x squared. So I'm going to line it up on top of the x squared up here. And then just like in long division, I take that number and I multiply it by the divisor. In this case, I'd have to distribute. So that would be x cubed minus 2x squared. Okay? And again, here's where you have to be super careful. Now we have to subtract, but we have to remember we're subtracting the entire thing. Okay, this is where people start to make a lot of negative mistakes. So what is x cubed minus x cubed is nothing. Then here's where you have to be careful. Negative 5x squared minus negative 2x squared. So that actually becomes a positive 2x squared. So that becomes negative 3x squared. Now, just like in long division, I'm going to carry down the next term. Okay? Now I sort of repeat the process. I look at the x here and I say, what do I have to multiply x by so that I get negative 3x squared? And the answer to that is negative 3x. So minus 3x goes up here. And I continue the process. I take the negative 3x times the divisor. So negative 3x times x is negative 3x squared. And negative 3x times negative 2 is positive 6x. Okay, I'm going to have to scroll up on my screen here a little bit. Okay, and once again, we have to remember we're subtracting, and I always put parentheses around it. That reminds me to be distributing that negative. So negative 3x squared minus negative 3x squared becomes a positive. That's nothing. And be careful here. 4x minus 6x is negative 2x. And one more time, carry down the next term, you get negative 2. Okay, repeating the process again. What do I have to multiply x by so that I get, I get negative 2x? And that answer is negative 2. So now I go ahead and distribute the negative 2. So I get negative 2x plus 4. Now, one last time. Remember, I'm subtracting the entire thing. So I put it in parentheses. Negative 2x minus negative 2x is nothing. Negative 2 minus 4 is negative 6. So that's my remainder. Okay, my remainder is negative 6. So just like what we did before in long division, we're going to put remainder over divisor. So up here, we're now going to put minus 6, because it's negative 6, over x minus 2. Okay, so now something to ponder. Do you think x minus 2 is a factor of x cubed minus 5x squared plus 4x minus 2? Okay, the answer to that question is no, it is not a factor, because we got a remainder. Whenever we get a remainder, we know that something's not a factor. For example, we would say 4 is a factor of 12 because when I divide 12 by 4, I get no remainder. But we would say 7 is not a factor of 12 because when I take 12 divided by 7, I get a remainder. Okay, let's look at another example. This one will have placeholders. Okay, example 2. I want to have 4x to the 4th minus 2x cubed minus 3x minus 9, and I want to divide it by 2x squared minus x minus 3. Okay, so this time my divisor is a trinomial instead of a binomial. But that's okay, the process doesn't change. My divisor is 2x squared minus x minus 3. And here's what I mean about placeholders. Do you notice that this dividend is missing the x squared. So what we have to do is we have to put a placeholder in place of the x squared. So it's 4x to the fourth minus 2x cubed plus 0x squared minus 3x minus 9. Even if your divisor was missing a term, you would have to put a placeholder there also, but in this case it's not. Okay, so now I say to myself, what do I have to multiply 2x squared by to get 4x to the fourth? And that answers 2x squared. So I'm going to line it up over my x squared term. This isn't super necessary, it just keeps it kind of neat and tidy. Now I have to take this 2x squared and I have to distribute it to the entire divisor. So that would be 4x to the fourth minus 2x cubed minus 6x squared. Okay, do you see if you didn't have this placeholder, you'd be trying to line up the 6x squared with the negative 3x, and that wouldn't work too well. Okay, so now I'm going to subtract the entire thing. So 4x to the fourth, take away 4x to the fourth is nothing. Negative 2x cubed, take away negative 2x cubed is nothing. And 0x squared minus negative 6x squared is a positive 6x squared. Okay, now, do you see how my divisor is a trinomial? I need that many terms down here in my division problem. So in this case, I'm going to carry down the next two terms. So if you're dividing by a binomial, you always need two terms down here. If you're dividing by a trinomial, you need 3 terms down here. Okay? So now I say to myself, okay, what do I have to multiply 2x squared by to get 6x squared? And that answer is a positive 3. So I put a positive 3 up here. And once again, I distribute the 3. So I would get 6x squared minus 3x minus 9. Subtracting the whole thing, you can easily see that this time we have a remainder of 0. Okay? So what does that mean? Remember, we're trying to figure out ways to factor these higher order polynomials. So if you look at this problem, whoops, got my whole screen on there now. Would you now say that 2x squared minus x minus 3 is a factor of 4x to the fourth minus 2x cubed minus 3x minus 9? And the answer to that is yes, it is a factor. Okay? The other thing I want you to realize in a division problem is we know that the quotient is equal to the divisor times the dividend. So what I could write now is that 4x to the fourth minus 2x cubed minus 3x minus 9 is equal to 2x squared plus 3, which is my quotient. Oh, that's pretty ugly. Fix that. Times 2x squared minus x minus 3. Okay. Now, I can continue to factor this trinomial. The 2x squared plus 3 is prime. But this trinomial here factors into 2x minus 3x plus 1. And as you can see, we have begun, or we have actually, factored this polynomial into these three factors. So knowing that, I can find the zeros if I needed to by setting each factor equal to 0. Now, one thing you have to realize is we were given this divisor. What we're going to be able to do by the end of the week is to find that first divisor. Okay, so that's the lesson for today. You can go ahead and do your test corrections and then your classwork. Hopefully it's working. Thanks a lot.